Hello, thank you for coming. I was playing with this idea of using WinDBG for my slides. Thing is, I'm not sure it's going to be very readable, so maybe I will use PowerPoint defeatedly. But I do want to show you that I really have slides in WinDBG. So as soon as you've become convinced that I have slides in WinDBG, I think I can stop showing off and just use PowerPoint. Plus, what I haven't thought about is that there is a clicker which will not work with WinDBG, but it does work with PowerPoint, so there's that as well. Yeah. Well, anyway, the subject of this presentation is automating problem analysis and triage. And the idea is we can take processes which we would do by hand for many years and start doing them automatically. So I'm going to spend just a little time on talking about dump files in general, and really just to show you, in case you haven't used dumps before, what the benefits can be from capturing dumps, gathering dumps from your production environment. But I'm going to spend most of the time on the problem of analyzing them automatically. So, for example, I have a client who has a production system which generates well, it depends on the period, but it generates hundreds of dumps a week. And they used to be doing this analysis by hand. So someone would sit, open each dump in a row, like the whole day, or probably more than a day, and they would just look at the problem, try to see if there's anything immediately obvious, and if not, they would just send the dump over to some other engineer. So there was a person whose task was doing this very computer-like thing of classifying dumps into categories, which is so boring. And so today, this kind of problem can be solved by a tool, by a library, by an API, which we will talk about mostly. The other kind of problem that you can solve is eliminating the need to change your code, to change your program in order to make it easier to debug. So today, you can build tools which attach to your application while it's running on a production system without stopping it, without suspending it. You can inspect what your threads are doing, what kind of objects you have in memory, look at specific objects individually, print their properties or whatever. You can see if there are any blocked threads and what they're waiting for. And all this information, again, is not just available from a tool that a person would have to use. This information is today available through an API, and the documented API, and an open source API, and an API that Microsoft built. So lots of good things about that API. So let's just start with a very, very brief discussion of why we need dump files, and then I'll just move on to the other part, which is that API I've mentioned. So the challenges mostly of doing production time debugging, as I assume some of you know, in case you've been doing production debugging for a while, the challenges are getting accurate information about the performance of your application in production, about crashes, about errors, about hangs, about threads that are just running wild and not exactly doing what you want them to do. And you need to do all that without putting very heavy tools in that environment. You can't install Visual Studio. You can't suspend your IIS server for 2 hours while you sit there and diagnose the issue. You cannot do that. And you can't run tools that are intrusive, that would inject a DLL into the target process, that would, again, suspend the target process, that require a restart of the target process. These things are unacceptable. So again, in the whole development process, so to speak, we already have agreed upon certain things that have to be automatic. So I guess there's no argument that we need automatic builds and automatic testing while we're doing those builds. It is becoming pretty accepted that we need automatic deployment. So when you build your stuff, you might also have a process for automatically putting it on a testing server or on a staging system, maybe even deploying to production automatically. So these things are pretty acceptable. But we don't quite always do today is automatic monitoring for issues, for performance problems, and for crashes. And we don't always have tools for automatically analyzing minimizing these issues. And then even if we do, we don't yet have tools for fixing problems automatically, so I'm not going to go there. I'm not going to try and tell you we can fix bugs by tool, but we can definitely do the first two things. We can diagnose things automatically and build a process in which people don't have to be involved with at least simple cases of production debugging. So just in very brief, dump files. Terminology mostly. We say user dump about a file that is generated as a snapshot of a running process. So we just take the process memory and we put it on disk in a file. Now, actually, there is some additional information that is also included, not just the process memory, but some additional stuff as well. But let's live with just a memory snapshot. The other term, a kernel dump, refers to a snapshot of the whole system memory that is used by the operating system. We're not going to deal with kernel dumps today, and the API I will be showing you, it does not support kernel dumps today. So it's only relevant for user dumps, for dumps of regular processes, regular applications, web apps, console apps, services, just not kernel and drivers. And dumps are useful, obviously, whenever you can't just attach a debugger and start debugging. And so the major two cases are, you have a process that crashed and disappeared, and so you can't attach a debugger because there is no process anymore. And the other case is you can't attach a debugger because there is no debugger. And it's a production system, no Visual Studio. You can't suspend by attaching a debugger. So all you have to work with is a snapshot of the process. Now, with that, you have to remember that dump files have limitations. Because it is a snapshot, you cannot place breakpoints and then hit F5 and see where you go, right? It's just a copy of what was in memory at one particular point in time. So occasionally, you will need multiple dumps, you will need to compare dumps in order to get some useful insight, information about your problem. And there's another little term, little taxonomy of dumps. You say crash dump when the dump was generated as the result of a crash. So there was an unhandled exception, the process crashed, you have a dump. And the other kind is hang dump, where the dump was generated as a result of just you deciding to do it. So someone decided you need a dump, you press a button, and you get a file on disk. So there's just names. The file format, and that's important, the file format is standard. It is not documented, but there is an API for writing dump files, and there is an API for reading dump files, and Windows provides that API. So whatever tool you use, you will get the same format, and you can analyze it using any other tool that supports opening dumps. So in terms of generating dump files, just a couple of tools that can help you do that, and we need dumps for analysis later, so I'll generate a couple of dumps like that. One option is Task Manager. You can just point Task Manager to a process, right-click, create dump file, you get a file. That's a hang dump, right? So the process didn't crash, you just decided you want a dump, so you click, get a dump. Another option is a great utility command line tool, which is free by sysinternals, called Proc Dump. It's a dedicated tool for generating dumps of processes, so Proc Dump. It has a huge number of switches, a lot of options. It can generate dumps immediately. It can generate them conditionally based on some future condition, some future trigger. For example, you can get a dump when memory usage is more than 500 megabytes, or when CPU usage is more than 90%. So you can do triggers. You can give it triggers, it will generate dump files for you. And one other option that I would like you to be aware of is using Windows itself. Windows has a feature called Windows Error Reporting, WER, and if you configure something in your registry, you will get dump files whenever an application crashes. Whenever there is a crash, you get a nice file written out to disk at the time of crash. So again, there's no lack of tools, and there are many other tools that can generate dump files. You can open dump files with Visual Studio itself, I'm just going to skip over symbols and show you in the demo. So you can open dump files in Visual Studio itself. Visual Studio supports opening dump files as of Visual Studio 2010 for .NET anyway, and .NET 4.0 is required. You can also open dumps with WinDBG, which is not the focus of this conversation, but there is a talk about WinDBG, I think, later today. So if you want to learn more about WinDBG for .NET applications, I think that would be a good place to go. But we're not going to spend any time in WinDBG today. So let me just show you a very quick example of what this process would look like manually. So I have over here somewhere a crashing application called File Explorer. And in my registry, I have configured that very registry key that was shown on the screen. And I have a dump folder, which will collect my dump files. And I have a dump type and a dump count. It's all on MSDN. It's all documented, right? So I run my little File Explorer. And sure enough, it crashes right during startup. And now there is this little dance that Windows likes to do, checking for solutions, finished checking for solutions, and the process is terminated. If you look at the folder, there is one file I generated to make sure things work at 424, and there is another that was just created now, 441. So these are dumps of that File Explorer process at the moment of crash. And I can put that in WinDBG or in Visual Studio and look at the state of the application when it crashed. So I'm going to do that later with maybe some other dump, but that's just for generating dumps for now. I also have another version of File Explorer which doesn't crash anymore, but it requires .NET Framework 3.5. Well, I can definitely compile that from source, but anyway, this application doesn't crash anymore. It just, upon a certain action in the GUI, it would hang. It would stop responding. So in that case, the registry settings we had would not help you. You would need a manual process for clicking something, for doing something to generate a dump. I will change the target to .NET 4.5 so that I can actually run it on my machine. There we go. And I'm just going to build. Yeah, sure, I trust you that the conversion worked. Right, so here's the app. And this time, when I double-click a file, it opens Notepad, but when I exit Notepad, the GUI just stops responding. Right, so I'm trying to drag the window, I'm trying to close it, nothing happens, it's stuck. So one thing you can do in this kind of situation is use Task Manager. This flashing is interesting, I'm not touching anything. It's just Windows has a life of its own. So I can just open Task Manager, navigate to that File Explorer process, right-click, create dump file, and while this is happening, the process is suspended, but then when it ends, I have a dump file right in my UpData folder. So really, again, there is no lack of tools for generating dump files, and there's also no lack of tools for opening them actually, but it is all a manual process. So for example, maybe I will, just for kicks, open one of these files. Just going to drag that into Visual Studio. Visual Studio is one tool that can open dumps. And you can see here it tells me that this process had an unhandled exception. The exception itself was an access violation. Maybe some of you recognize the exception code, and there's also a description. It says the OS version was Windows 10, the .NET version was 4.6, and if I just click debug on the right, then it will bring me to the line of code that crashed, as well as the call stack and everything else, after loading debugging symbols for my code and for Microsoft binaries. I'm not going to go too deep into symbols right now, but you need them to do analysis. And now it's asking me where the source code is. It doesn't find the source code itself, so I'm going to point it to my demos folder. Here are the sources. And as soon as that happens, I see this nice window here that says there was an exception reading location 0. So that was the exception itself. And when I break, it puts me on the line of code that crashed. And so specifically here, this is the part that crashed directory get files node.name. What could be 0? What address could be 0 here? Node, right? So I can just hover over node and see that it is indeed null. Now, I realize if you've been looking at dumps before, then this was 10 minutes that you've already done a lot of times. But even if so, this is instructive because there's a lot of manual labor, a lot of clicking, a lot of dragging files around, right? And if you have to do it 100 times a day, every day, you will quit very quickly. I'm sure you will. And I hope no one here will ever have to go through that kind of thing. So we're now switching gears, and we're going to do the same thing, solve the same kind of challenges, but on a larger scale with a lot of files using a library instead of a person that has to click things in order for it to work. Okay, now if you do have any interesting things you want to talk about dumps with me, please feel free after the session. We can discuss dumps at any detail you'd like, but it's not the focus of my presentation today. So first, what people used to do, like for the last decade, before automatic options were available, is just automate debuggers in very, very, very trivial and on the other hand, ugly ways. So for example, I'm not going to even try and explain what's going on here. You can write a batch file that will take all the dump files in a given directory, and for each dump file, it will launch CDB, which is like WinDBG, only it doesn't have a GUI, it's just a command line, a console, and then it will have that instance of CDB run a few commands, put them in a log file, and then move on to the next dump file. And then once you have all these logs, you can maybe write another loop that will run over the log files, and it will extract from them some kind of magic string, and then determine what exception occurred. This was state-of-the-art once. Hopefully you see it's not really flexible, and it's also very, very ugly, and it relies on internal implementation details, so if any strings change, this just breaks. I have clients who have very large systems built on top of this. They have bash scripts that run analysis over files. Yep, seriously. So instead, we now have in the 21st century, we now have ClrMD. ClrMD is a nickname. The library is actually called Microsoft Diagnostics Runtime. And this is an API. It's a .NET NuGet package for interacting with the .NET debugging engine. So you can use this to analyze dump files, which I will in just a minute. You can also use this for live debugging. So it's useful for dumps. It's also useful for live processes. You can attach to a live process and start doing some interesting things, including if you want actual debugging, actual breakpoints and whatever. We're not going to do breakpoints today, but you can definitely look at threads, look at objects. You can do that with a live process, or you can do that with a dump. And there are already some interesting projects built on top of ClrMD, even though it's still in preview. It's pre-release, and it's better right now, and it's hopefully going to be released early next year. It is also open source, of course. As I've already said, Microsoft open sourced it a while ago. So let's take a look at a few concepts and then write some code. ClrMD has this large encompassing class called data target. A data target is an abstraction of something you debug. It can be a dump, or it can be a live process. Maybe in the future there will be more targets, but right now we have dumps and live processes. Inside a data target, you have CLR runtimes. So usually you only have one CLR loaded in your process, but you can theoretically have more than one. And then you have instances of CLR runtime for each runtime you have loaded. Inside that runtime, you have threads. You can look at threads, call stacks, exceptions. You have the heap, so you can look at objects and types and fields. And you have a bunch of additional concepts not depicted here. But basically, you can look at the inner workings of a live process or a dump file using plain C# code, which is pretty well documented too. So let me show you a quick example. This code is also on the slides, but I'm going to write it over here. So I'm just going to create a new project, and let's pray the NuGet gods are with us so that I can actually install the necessary NuGet package. So I'm going to call this ClrMD .next. It's just a console application, and I will now add the ClrMD NuGet package. Yeah, it's not installed, obviously. Browse. Great, so the search worked anyway, and here's the NuGet package we need, and I'm gonna click install and accept the license as well. And now I have a reference to Microsoft Diagnostics runtime. All right, so let's write a little code. I'm gonna start over here with creating a data target. So data target has two static methods attached to process or load crash dump. So let's start with dumps. I'm gonna also increase the fonts a little bit. I don't want you to hurt your eyes any more than you have to. So I'm gonna load a crash dump from over here. This is the one. Copy as path. And this gives me a target. Now in that target, there is a collection of CLR versions, one for each runtime loaded into that process, or it might be an unmanaged application, and then no runtimes at all. But I'm assuming there will be at least one, and I'm gonna do create runtime here and get a runtime object. And now that runtime has a collection of threads. Interesting. So let's do for each thread in runtime.threads. Now threads, they have a call stack. They also have a current exception property. Now this just writes itself, right? So if the thread has a current exception, that is interesting. This is the thread that caused the crash. So let's print the current exception and the stack trace. So just, console write line, thread current exception dot message, and thread current exception dot type. And then the exception also has a call stack. So for each frame in thread current exception stack trace, each frame is a function on the stack, right? So I'm just going to print frame.displayString. So in about, I don't know, a screen full of code, but with very, very large font sizes, right? We have something that can open a dump file, identify whether there was a thread with an unhandled exception, and print out the details of that exception. And this is something you'd need a person to do previously, by dragging things into Visual Studio and clicking buttons. Let's see if it actually works. So I'm going to hit Ctrl F5, and I get an exception that says mismatched architecture between this process and the DAC. So without getting into what the DAC is, and it's actually, you can't see that it says DAC. There we go. Without actually going into details on what the DAC is, ClrMD, as well as generally .NET, the CLR debugging API, has a limitation. You can't mix bitness. So if your debugging tool is 32-bit, you have to debug 32-bit stuff. If your debugging tool is 64-bit, you can only debug 64-bit stuff. That's not a big problem, you just need two versions. So I'm just going to switch off the prefer 32-bit button, checkbox that they added at some point. And now if I run, then this is the output from the actual crash. So we have null reference exception, object reference not set to an instance of an object, and then you have the call stack for that crash. So this is the same place it crashed which we saw in Visual Studio, some method in the main form, whatever. But we do have the stack. And the source code is also available. So you just have to call a couple more methods, and you can retrieve the source file name and line number, and then you can access the source file and just print out the source if you want. So this is obviously useful. You can take a full directory full of dump files, just run over every file and produce some useful reports. You can do aggregation, like which module had the most crashes, which developer had the most crashes. You can file bugs automatically. And in fact, I also have a client who built a system that does that. They analyze dumps and then they file work items in Redmine using data from ClrMD. This is something a person used to do, and now a tool can do. So I know you developers love people replacing you with programs. That's why we are in this after all. Right, so let's just go back, and I want to talk about a couple other more advanced things that you can do with ClrMD, and also leave a couple of minutes for questions, because this is really open-ended, and you can build a bunch of different things with this API. So one other thing, after basic exception analysis, one other thing you can do is inspect the heap. You have APIs for enumerating all heap objects, for finding the type of each object, for printing fields of objects. It's basically kind of like reflection, but on another process, right? So it's not reflection, it's not in your app, it's in another process or a dump file. So let's take a look at a couple of examples. I'm just gonna keep this code over here and do a return right before it. So this time my target is gonna be a live target. I'm gonna do attach to process. And this takes a process ID, so I can do process, get processes by name, dev.env, number 0.id, so just attached to the Visual Studio process. It takes a timeout, how long to wait before the attach is deemed unsuccessful. And there is a very important thing, an attach flag. It takes 3 options. Invasive attach is what the debugger does. It's like you attach a debugger to that process. This is not something you want to do in production. You don't want that. Non-invasive is not like attaching a debugger, but it still suspends the process. It stops the process temporarily. So again, not for production, usually. Passive is just nothing. It doesn't really do anything to the target process. It just lets you use the APIs as if you were indeed attached. So I'm going to use passive here. I don't want to crash my Visual Studio while I'm doing stuff here. So we have that live target, and it also, of course, has CLR versions, and I can create a runtime object that represents my CLR version. Hopefully Visual Studio only has one CLR inside, let's hope. And now we can do stuff with the heap. So just runtime get heap. And we can do, for example, enumerate object addresses. So this just goes over all the heap and returns all the addresses of all the objects. Now, an object has a type which you can get from getObjectType. So this is getting interesting. Maybe we can do a Linq query. So instead of this, let's do from obj in heap enumerate object addresses. Let type equal getObjectType of obj. And then maybe we can do a group obj by type.name into G. And then maybe we can, I don't know, order by. So let count equal G.count. Maybe order by count descending. No, actually ascending would be fine. And then select new type G.key count count. So I realize there's a bit of code here, but it is all pretty obvious, right, once you look at it. We have just grouped objects by type. And so now we have a count of how many objects of each type Visual Studio has. Now, when you do this kind of thing, and the process is still running, there can be inconsistencies. So the process is running, and there are garbage collections happening, and objects are being created. So this can be a little tricky, and so I already know that I need to do a couple of checks first. So I need to make sure the type is not free, and also that the type is not null, in fact, because it will sometimes return null, and that the type name is not null as well. So that's just some basic sanity checks. But once we have that, I can just print all the pairs produced by that query. Okay, let's try this. I hit Control F5 and I have build errors because I already have a runtime variable. Well, you're just going to leave in a comment from now on. Goodbye. All right. So this produces another exception, but one that we already are familiar with, duck architecture mismatch. What's the reason? Visual Studio is a 32-bit process, and my analysis tool is now 64-bit. Okay, so just gonna create a new configuration real quick. x86, create, okay, close, compile, run. Let's see. Okay, yeah, should have put a not in here. But it did work, right? Yes, well, are you surprised that Visual Studio has a lot of different types on its heap? It does work very slowly. I think most of the time was printing anyway. Now if you look at some of the results, you can see 100,000 strings and some weak references, runtime types, objects, arrays of objects, and so on and so forth. You can also do this with sizes, right? So I have grouped by count, but there is also a function that gives you the object size. So you can group by size. And then you are this close to writing your own memory profiler. Right? That's basically what the first thing that a memory profiler does is give you statistics on what objects you have and how much memory each type is responsible for. So you can definitely build some more sophisticated things as well with this, because you have what I like to call the GC API. So basically you have functions that enumerate GC roots, that enumerate references from one object to another, so you can travel your heap like a graph. There's a bunch of cool stuff there, but I'm going to stop for the heap anyway. That's just a couple of the things that you can do. Yes? Right, so the question is, the get heap method returns just one object, and you might have learned that, for example, in server GC you have multiple heaps. That's what you're probably referring to. Well, what you can do with the heap object is enumerate the heap segments, and the segments have heap assignments, but there is just one logical heap object that just wraps the whole thing. You can still know that there are different regions in memory, actually, in reality, but the heap object just wraps the whole thing. Okay, I'm not sure I have time for a more detailed demo on the heap, but I just want to mention that the type class has a fields property, which gives you all the fields the type has, and you can get the field values from each object as well. So just imagine, for example, attaching to an ASP.NET application and printing out all the currently executing requests. Or maybe attaching to WCF service and printing out all the logical operations that your service is currently working on. Or maybe all context objects from Entity Framework or Linq to SQL or in Hibernate, whatever, and the SQL statement that they are executing right now. So basically you just have to decide what type you care about, and you can look at that type's contents whenever you want. Yes? Well, so the question is, can you change things? So no, you cannot. Well, I mean, there is nothing that stops you if you go beyond the API. So for example, there is a way for you to find the address of that object in memory. So you can write your own code that will just write another value. But there is no API in ClrMD for doing that. Besides, if the target is a dump file, there is nothing to change. So you can change, it won't matter. But yeah, that's a good thing you can do if you just use some external features. Yes?
Есть там какие-нибудь триггеры на создание объектов, либо там, чтобы можно было привязаться к какому-то событию?
Okay, so the question is, can you receive events from the target? For example, whenever, I don't know, there is an exception, or whenever an object is created, or whatever. So the API itself has, it wraps the .NET debugging API as well. Like I've said, you can set breakpoints, for example. So yeah, you can set a breakpoint somewhere, you can receive exception events. It is not exactly designed for that, because it only has this nice, these nice wrappers for the things I've mentioned, for mostly analysis and not live debugging. But the .NET debugging API is just basically a collection of COM objects, which are well documented, and you can use them to do stuff like what you're asking. But ClrMD is just not going to help you very much in that case. It will just sit there and give you a reference to some COM object that you have to now work with. Yes? Okay, so the question is again, in relation to events, can you, for example, generate a dump file automatically when the number of some objects is beyond, I don't know, 500,000? There is nothing built in like this, but you can, for example, use ClrMD to check every 5 seconds how many objects you have of a certain type, and then there is a Windows function that generates a dump file. And you can easily use pinvoke to just talk to that, and there's also I have a library on GitHub that wraps this in a .NET object, so yeah, you can do that. Okay, how are we on time? I don't have a watch. I think we have 13 more minutes, right? Yes? Okay, so what are the differences between the various attach flags? Okay, so yeah, well, I'm going to answer briefly. If you want something more detailed, come later. Attach flag passive means there is no debugger attached. The process doesn't know anything happened. It is still running. It is happy. The other two suspend the process. The only question is how. So the non-invasive version just suspends all the threads, but it doesn't use the Windows debugging API. It just stops all the threads. The invasive option uses the Windows debugging APIs, which has additional features, but it also means, for example, you can only have one debugger. So if you already have a debugger attached, you cannot also use this API in a different process. Again, for production use, you probably want passive or non-invasive. If you're building some kind of debugging tool, you might find invasive useful because you get more features. I really love your questions, they're very good. I just want to mention and maybe show you, if you'd like, just one final thing, which has to do with blocking, with weights. So ClrMD has an API for enumerating the blocking objects, the things your threads are waiting for. So for each thread, there is a simple blocking objects property, which just tells you what the things the thread is waiting for are at this moment. And these blocking objects have a bunch of additional details as well. So for example, they have an owner if it is available. So if you have a thread waiting for a lock, you can find out who is holding that lock, who is currently in the lock. If you have a thread waiting for a reader-writer lock, you can see the list of readers that are currently in that lock. So a bunch of things like that are available. Just to show you very quickly what it would look like, I have that deadlocked application, that hang from previously. So we can do something like, let me just, again, comment out this thing. I can load crash dump from that local app data temp folder. Here's file explorer. Over here, just gonna, didn't copy as path. Come on, copy as path. So just opening that dump file of the hanging app, and now runtime is dump Sela versions create runtime, and now for each thread, for thread in runtime threads, so for each thread, I have this blocking objects collection that I can work with. So I'm gonna print out. Sorry, it's really hard to type while standing at this weird angle. Thread whatever, thread.os thread ID, and then for each blocking object in thread blocking objects, we can, what? Come back. Right, we can print the blocking object reason, for example. So let's do blocked on and then the reason. And we might be able to discover the owner as well if one is available. So here I can do something defensive just for the demo. If BO has single owner and BO owner is not null, then I'm going to print also owned by thread and then BO owner OS thread ID. Now, obviously this needs some work because some objects have more than one owner. For example, reader-writer locks, they can have multiple readers inside, so there could be multiple owners. And this code needs some more work, but this is the general idea of what I want. If it works, again, we have the architecture mismatch. So just recompile again as any CPU and run. If this works, then we can see that this application's threads are in fact in a deadlock. So we have thread 63448 blocked on a monitor, which is a lock, owned by thread 5804. And that thread 5804 is waiting for a lock, which is owned by thread 6348. So these two threads are waiting for each other. Of course, if you have a bigger loop, a bigger chain of weights, you will need some more sophisticated analysis. You would have to travel along this list of waiting objects, but you can build weight relationship graphs like that. You can determine what your threads are waiting for and get ownership information as well. This is also very useful for diagnostics. Again, just think of something like this in production. You can see all the blocked threads, and if you get the stack, you also know where they're blocked, like in which component, in which module, in which function, whatever. You just get that from the stack. So this is very, very powerful again. I do want to leave a couple of minutes for questions, so I just want to wrap this up. We can do automatic analysis today with ClrMD, but it's not just for dump files, as you can see. You can apply this to live processes, and the possibilities are limitless here. You can build tools that find objects at runtime and print their details, or maybe even change them. You can build tools that detect hangs and wait situations. You can print memory statistics for your processes. You can build reporting on top of this. It's a very powerful building block, is what I'm saying. And the library is in active development, but if this is something that really is interesting for you, not just as a user, they do welcome contributions. And currently at Microsoft, there's just one guy working on this, and it's not his main job. He is a support engineer. This is a side project for him. So this really needs help from people like you. Anyways, if you were scared of WinDBG and all the manual commands you have to type in, you can now build your own in C#. So my Twitter is here, and I'm going to post the demos I've shown you and the slides, of course. We do have, I think, 5 minutes for questions, so I'll be very happy to answer. Yes? Yes?
Do this library have a network debugging capabilities?
Okay, so does this library support remote debugging of some kind? No. You can, again, build some kind of agent that sits on a remote system and talks to the host. This is what Visual Studio does. This is what WinDBG does. This is what the JetBrains profiler does. You just have to build it. Yeah. So how can... Just going to repeat the question, how can you defend yourself against being debugged by this? Well, there are actually, it's a serious thing, there are actually anti-debugging solutions, not just for .NET in general on Windows, tools that detect a debugger and try to defend against it. The thing is, these APIs, they don't really require a debugger attach. So what I've done here is just using passive support. All the tool does is read, actually not write, just read the process's memory. So if you have access to the process, I don't see what the process can do to stop you from reading its memory. It's just you open a handle and you can read memory. And this doesn't require anything else. You can use obfuscation tools and so on to make the code harder, but you can't really defend against just attaching. Okay, so the option for passive attach, does it depend on a .NET version, on the Windows version? No, it's just that it just reads the process's memory. It works with all versions that this library supports. And this library supports I've used it extensively with .NET 2.0 and it works fine. Haven't tried older versions, but yeah. Mm-hmm. Yes?
If I understand correctly, is that the passive attachment, it doesn't create a real snapshot, it's a dirty snapshot. So the thread that reads the memory process and the processor are running in parallel. Am I right? You cannot read a memory of process without stopping it and have a snapshot that is real snapshot.
Okay, so the question is, your understanding is that passive attach suspends the process and takes a snapshot. It doesn't. It doesn't suspend. It doesn't take a snapshot. And yes, the view of memory that you get can be inconsistent. I think I've even said that. So, for example, when you go over all the objects on the heap, obviously there's some changes from the point you start to the point you end. You have to deal with them. If you want passive, you just have to deal with that. Yep. There is just one last comment. There is an API in Windows since Windows 7, which lets you, it's not part of ClrMD, but it lets you fork a process, just create a virtual memory fork of the process, and then you can attach to that. And the original process keeps running, and you work with that forked VM, virtual address space. It's a lot of work, but it is doable, so this is a possible way to deal with your problem. Yeah. Okay? Right. Well, if you do have any other things you want to talk about, then please feel free to talk to me. There is a WinDBG talk, I think, in the next slot, or maybe, so this can be complementary, just give you a different point of view on what people like to use for debugging .NET apps today. Thank you very much. Anyway.